chemicals that are incompatible with each other. Magnesium and silver nitrate are one. Now when you mix these two together, you produce an explosive. It's almost like a flash powder. It's got a very dangerous property in that one speck of water can set it off. So magnesium, I'm going to pour out a small amount. There it is. Put that all away. I've got some silver nitrate here, and it's in a dark bottle because it's reactive with light. So silver nitrate's an oxidizer. Magnesium is a fuel that burns really, really hot. And I mix them together, put them on the mat. Now all I need to do is ignite it. And this is my ignition source, a drop of water. We fizz then. Missed it completely. Look at the magic skills. Oh, come on. I hit it bang in the centre then. How did I miss that? There we go. That definitely got it. Definitely got it. Ooh. Oh, jeez. That is bright. So that's spontaneous combustion of magnesium, and it's filling the place up with...
So we're on to hazard class 4, and that's flammable solids. And there's 4.1, 4.2, and 4.3. So you have flammable solids is 4.1, spontaneously combustible is 4.2, and then water reactive is 4.3. And so you have the different designations by the colors, right? Even though they all have their flame to them, just remember that these are solids, they're not liquid material. Hazard class 4 is important because it can typically, when you're using the emergency response guide, push you to the green pages which have evacuation zones associated with it. So there typically is an inhalation hazard or some other kind of hazard associated with when these items leave their container, if they mix with air or water or whatever it is that causes them to readily undergo ignition. So for some definitions here, so we have 4.1 is usually these are wetted explosives, and when they're sufficiently wetted, it suppresses their ability to explode. So they just basically become thermally unstable. And then 4.2 is spontaneous combustible, and these will ignite without an ignition source and or within 5 minutes after coming in contact with air. The 4.2 can be both solids and liquids, so these are again some of the most nasty agents that are out there. And then dangerous when wet. As you can imagine, if an emergency responder was coming in, they'd need to know that the material was dangerous when wet, and that would be it is likely to give off flames at a rate of 1 liter per kilogram material per hour. So basically liberate material rather quickly. Okay, so if you take a look at the periodic table in the back of your texts, you'll see that these are air and water reactive down here, these metals. And here's another set that are highly reactive. You also have highly reactive ones here. However, we're relatively stable over here. So just by looking at the periodic table, our alkali metals are water reactive and possibly air reactive as well. And in here, for example, barium, strontium, magnesium, these are also air reactive. So the elements that are looking for to fulfill their outer ring tend to be more reactive, but metals, in particular the alkaline metals, are special.
I'm working with some lithium metal very difficult to cut. I've got a piece of sodium here, pretty easy to cut. You notice when I cut through that the fresh sodium is very shiny compared to the rest. Let's zoom in real quick. Let's see if we can really get in there. So this side will reflect a lot of light. The other sides are pretty dull. And you'll see that especially with the potassium here. I'm going to go ahead and give this kind of a half cut. So for the potassium, this is the side that's freshly cut, and you can see the dullness to the other sides compared to that one. So I'm going to go ahead and take those three, and I'm going to add them to water, and we can look at the kind of reactivity of those three alkali metals with water. So here I'm going to take the lithium and add that to the water. It's going to generate hydrogen gas and lithium hydroxide. So you're going to see a pink color develop here, and then you're going to see some smoke come off, and that's either lithium metal or that's lithium hydroxide coming off of there. Maybe a little bit of liquid water. But it's not as reactive as, say, sodium, so I'm going to put sodium into the next one. And the sodium is actually probably going to ignite. So you'll see some orange flame perhaps, or some sparks, or some shrapnel. And then the last one, I'm going to go ahead and put my two pieces of potassium in that I've cut in half. So this is less potassium than the other two in terms of amount. You'll find that the reactivity is a little bit greater. Now that potassium there was quite reactive there, but the sodium sometimes will allow hydrogen gas to build up. In this case it's not igniting, but we can try adding another piece here. And we can hope that that's going to go ahead and actually send off some shrapnel and some flame. All three produce hydrogen gas, all three produce hydroxides. There's your alkali metals. Next we're going to go ahead and do the rubidium and cesium.
Okay, so we've looked at our hazard class 4, which is flammable solids, and we have spontaneously combustible, dangerous when wet, and flammable solids. And that is 4, and then we move on to 5. And so 5 is oxidizer and organic peroxides. So remember, an oxidizer in and of itself is not flammable. You cannot catch an oxidizer on fire, but once you do catch it on fire, it liberates heat, so it makes the fire basically hotter, right? That's why they add oxygen to fuels so that they'll have more energy. And so 5.1 is an oxidizing agent, and 5.2 is the more nasty one, which is the organic peroxide. And that was the one that we watched the video of. And so it just liberates all this oxygen, and it's specific by this peroxy group. You see a lot of O's with our organic peroxides. Hazard classification 6 is toxic and infectious materials. And 6.1, I can't imagine you would use these. These are chemical warfare agents. And more likely 6.2, which is considered infectious substance disease-causing agents. And the word poison and toxic are synonymous. They can be interchanged with one another. Certain classifications need more attention to detail. Designations need to be defined when you're doing shipping papers. That's true for Hazard Class 4, and it's also true for Hazard Class 6. So anytime the agent can give off a toxic gas, it must be marked and say inhalation hazard, even if it's a non-flammable gas. So sometimes there's multiple markings when you're looking at biological agents. Radioactive material is Hazard Class 7. There are special labels and rules related to radioactive material. We're not going to cover it in this particular course. The two hazard classes, the two most predominant hazard classes, are Hazard Class 8, corrosives, and Hazard Class 3, flammable liquids. So these two are going to make up a majority of your inventory. And so Hazard Class 8 can cover either a solid or a liquid that causes irreversible damage to skin or metal materials over a period of time. And it's a liquid or solid that can become a liquid during transport. One thing that's important about Hazard Class 8 is being able to differentiate between bases and acids, because storing and compatibility are highly related to that physical characteristic. Just like with flammable liquids, its flash point is an important factor in how you would store it with like materials. The tanker truck with consecutive rings, that's a complete circle, indicates high probability that the agent inside is a chemical hazard, such as a corrosive material. Whereas a more oblong, more egg-shaped tanker without the concentric rings indicates gasoline. And that's because the rings strengthen the tanker, and also the baffles stop the sloshing of the materials back and forth, which sometimes add to the reactivity of acids and bases. Corrosives are special ones to deal with. They need to, people really need to understand the implications of not following the rules. So we have acids, and acids burn, and we have bases, and bases dissolve. So most cleaning agents, drain cleaners, are alkaline so that they could destroy the grease. We use acids within our treatment plants to help kill bacteria. Sulfuric acid is used in the oil industry. We use in other kind of cleaning agents. So corrosives are used in lots of different places, and we're used to seeing them. So ammonium hydroxide, potassium hydroxide, right? These are our oxy groups. So these are our bases. They're not our acids. Our acids are nitric acid or hydrochloric acid. And so you could, some common uses for these would be depending on what type of industry you're actually in. Hazard Class 9 is the miscellaneous category for items that present some risk during shipment or an annoyance or discomfort to crew members due to noxious fumes, and also elevated temperature material. So asphalt. And a list of some items in hazard classification 9: life rafts, lithium batteries, first aid kits. And right here is where the shipping papers indicate what hazard class. And this also is important when you're looking up the material, being sure that the UN number and the hazard class match when you're looking at the hazardous materials table. And so the categories are important. They help us in determining how to ship appropriately and responders how to respond. And they give important information relatively quickly when the shipping papers are filled in properly. And when not, they could add to some pretty large fines. Thank you.